Okay guys, this is our third video, and now in this video we are going to say a simple breaker, 33 kV breaker drawing. So whatever I have said in previous videos will be helping to read this drawing. And before going directly to the scheme, we have to check. First one is nameplate details. Then this is nameplate details. Okay, the type of the breaker or type of this one is shown here, which is OBF BBF 36 point. Okay, this is the type of circuit breaker. You should match with your actual breaker in the site or actual equipments in the site, and then only this drawing will be applicable to that breaker. If there is a variation, then you cannot use this drawing for that breaker, which has another model number from this number. Okay, so this you have to check everywhere. First the nameplate details, then second one is the components locations. That is main, because the components which is used in our wiring drawing and the overall location, you should have idea, because if you don't have that idea, then when you are going for a rectification or a troubleshooting in a wiring, then you may not able to find out that particular component which you are looking for troubleshooting. Otherwise it may take more time to you to find out the locations. So here they have given the location of components. There is this L1, L2 is a, they have given 7 number. Item description they have given 7. This is, you can see, Technic make 110 volt DC LED lamp, red color, 7 number. So quantity also you have to check how many numbers, that is 1 and 9. Okay, 9 number. They have given numbers and their details description it is given here. So this is called legends and or otherwise bill of material. You should be familiar with this before going to the before going into the scheme. So this you can see here it is 5 number. So you can see 5 is local remote selector switch and the company is switch runner. This is a ABB make breaker drawing, 33 kV breaker drawing. So every manufacturer will have different way of description. So that further we will see in another manufacturer drawing. So before going into the scheme, you should see location, and then third one is the items which are used and the descriptions and how many numbers. Okay, and this you should refer. Then you have to go back to the what do you call it, scheme drawing. Okay, now our scheme starts from here. You can see in previous videos that J is used for main DC, so J1 J2 also. So the same way, one is used for positive and 2 is used for negative. So J is the main DC, that means the DC auxiliary supply from remote, that means it may be from DCDB or somewhere else, the incoming supply. So this is your incoming supply, so which will be denoted using J1 and J2. And these terminals, these are all terminals. These also have mentioned in the drawing. Yeah, here each and every components and the symbols are mentioned in this legend drawing. And this also you should refer before going into the what do you call it, schematic checking. So this the closing coil and tripping coil, they have given number F01 and CC, TC1, TC2, and circuit breakers contacts, main contacts are mentioned using this symbol. And this is thermostat, and we will see what is the use of thermostat also. And heater will be mentioned using like this symbol, and it has a number F10 and 01. Okay, and the 3-pin socket, and this has a number A301, and illumination lamp G112, the number, and then motor, that is will be mentioned using this symbol. And MCB, they have 3 MCB 1, 2, 3 that we will see there, and NC contact, NO contact, and indication breaker on, indication breaker off. And I'll tell you what is meant by NC contact and what is meant by NO contact. And here see, terminal of apparatus and terminal block in control box, and this is terminal block in control box for remote connection. So apparatus, this they have mentioned apparatus. So this is the, suppose if you have a toggle switch, it has the ROM, that means there is a place to wire up. So these terminals, like apparatus terminals, will be using this symbol, and terminal block in control blocks, TB we call it. That means there is a place to wire up our wires, and that is called terminal blocks, and that terminal blocks will have symbol this one. Okay, and if you are doing any external connection, that means from remote and or some other panel, that will be terminated in this TB, and that TB will be mentioned in the drawing like this. Okay, and this is your local remote selector switch, and this is your breaker control switch. Okay, and then we have what do you call it? And their numbers also given. It is actually bulk quantity added. That's 130 numbers they have given, but and they have given the location of sheet number. So where these components are shown in our drawing, sheet number. So here now we are in 3. If you want to see this symbol and where it is used, then we can go to the sheet number 5 and second column and see row. So this is the place, this is where the place that component will be shown. Okay, so this is the location sheet number reference. Okay, these are standard. Okay, to define a location of a component. You can see that for suppose this MCB will be showed 7th way and 7th, this P1001 will 7th sheet and second column and B row. This location of MCB will be in the schematic drawing, and this is the location, and 02 is at 5 and first column and first row, and also first column and fourth row. Okay, and yeah, so now you understand actually this what is actually this all means. Okay, and they have mentioned the which company's component they have used. Here you can see the manufacturer. Here you can see the manufacturer name. Okay, so main thing is you should know legend and bill of materials and location of the equipment for troubleshooting. So prior to going into the schematic reading, schematic analysis, so you should know these things. So, and these symbols I have mentioned in my previous video, and I have given in description. I have shown you the I have attached the files, so you can download it from there, and it has all the symbols which will be used here. And this is your breaker control circuit, T and switch. And I forgot to tell you that, and I'll explain you this, what does it mean by NC contact, what does it mean by no contact, because this is very important and this will be used everywhere. Most of the drawings will have NC contact, and most of the component will have NC contact. So what is mean by NC means normally closed, and NO means normally open. What does it mean by normally closed, and what does it mean by normally open, that we will see later. Okay, now this is our actual scheme. So this is actual scheme. We have what number of pages? 3 number of pages. Okay, so this drawing I have taken just show you that whatever I have said in my previous videos, that is whether applicable to these or not. For that one you have chosen this drawing. So here you can see. So main DC I said it will be mentioned by J. So main DC supplies. So here they have J and here also J, and for positive they use odd number suffixing. So here is J1, and negative even number suffixing. So then J2. Then it goes to where this is they have mentioned B1002. B1002 is nothing but MCB. So after the MCB, it goes to the TB, terminal block on the breaker side. Okay, breaker cubism, and it is connected to the 177 number terminal block, and there is a link to the 178 terminal block. So I said after the MCB it will be the ferrule will be K1. The breaker control circuit will have K series, okay, ferruling. So this is K1. This K1 travel from the it has looped from TV to this local remote switch, and then contact and local remote switch contact 1P1 1P2, another 2P1 2P2, and here also 1P1 1P2, and then 2P1 2P2. And now okay, here you have to you should see that this is and this one is separate track. In future videos we will see why this link is provided. That means in future videos when we see about trip coil 1, trip coil 2, that time we will know why this loops and all everything. So if you want to use separate DC, there are some substation which will have independent DC. Two DC sources. In that case we can connect this trip circuit separately by removing this link and through MCB. Okay, so that's why they have given this provision. And negative also going here and looped here from closing coil 2. So closing coil 2, and then what you call it, anti-mapping device, and then trip coil 1, trip coil 2. And this is your breaker mechanism box, and this is your control cubicle. So there is an interconnection between breaker control cubicle and then mechanism box. Okay, in mechanism box what we have is, so these are all NC and NO contacts. So I'll explain what does it mean by NC contact and NO contact. So we know NC means normally closed and NO means normally open. Normally closed is nothing but, and if it is a breaker contact, that means breaker auxiliary contact. So breaker has main contacts which are connected to the HV systems, and for replica of that means breaker position, we have auxiliary contact in the control cubicle, and that replicates actual position of the breaker main contacts. Okay, and so this contact when the breaker is in normal condition means if there is no supply given, it is not closed, and in that case, so the contact will be, the NO contact will be open position, and NC contact will be closed position. This is our NC contact, and this is our this is our NO contact. Okay, so this NO contact when the breaker is not closed, that time it will be open position, and this contact will be in closed position. So normally closed, so that's why they call normally closed and normally open. But the breaker closed, once the breaker is closed, this normally closed contact will change its position to closed position to open, and this normally open contact, normally open means when the breaker is not operated, it is in ideal condition. So when the breaker is closed, it will change from open to closed. So this is the difference between normally closed and normally open. And now I talked about breaker auxiliary contact. Suppose if it is a spring charging contact, spring charge contacts also will be named normally open spring charge contact, normally closed contact. That in that case, normally open means the spring is in discharge conditions. Okay, and I hope you understand. If you have any doubt, you can comment on my videos so that I can reply you. I can explain you. Okay, so now the positive come to local remote switch. So here local remote switch. So we can control the breaker. What is the purpose of local remote switch? So we can control the breaker from locally, or otherwise we can control the breaker from remote end. So when you are operating from locally, that for selection of that one, we are using local remote switch. So if the breaker, so we are here you see a dot, block dot. So it means that it is connected. These two contact will make that means the circuit will get through from 1P1 to 1P2 when this switch is in position L, that means local position, then only it will the positive will extend it from 1P1 to 1P2. Suppose if it is in remote position, this will get open so that there won't be any connection from 1P1 1P2 at the remote position. So the positive will not get extend here. Okay, and as I said, odd numbering will be done. So here K1, and after this one to this one, then it is K7. Now it is the fairy will change to K7. We put the switch in the local position, then it will change, the positive will extend to K7. Now K7, we have the K7 is connected to TNC, that means trip close switch. Okay, and this switch here, you should see this is a 2 position switch, and this is a 3 position switch, and this is also spring return. So spring return switch, that all have mentioned in your legends. You can go and refer there. So when here also it is this dot is mentioned at C. It means that whenever this switch is at position C, then only this positive will extend from K7 to, that means 1P1 to 1P2 at this switch. Okay, so suppose if I turn this switch to close position, then the K7 will be forwarded to 127 TB. Here they have connected to a TB and 127, 128. And this is actually for if you want to add any other circuits here, like interlocks or something else. For that only they have provided this provision, and it goes to where 94. So 94 is, you can see this dotted line shows that this is operated by this coil. This is nothing but an anti-pumping device, the anti-pumping relay or device. We will talk about this later in separate session. So as of now, it is a coil. Okay, and it has contacts, normally closed or normally open. So anti-pumping, when it doesn't get any supply, that time it will be, this contact will be 7 number and 11 number contact will be in closed position, and 4 number 12 number contact will be in open position. So now our positive is extended here up to this. Okay, now this is breaker in open position. So it means that when your breaker is open condition, this is breaker contact, breaker auxiliary contact, open condition, then only you should close your you can close your breaker. So if it is already in closed position, because of this contact, it will get open only when it is closed. When the breaker is closed, the positive will not extend here. Okay, and these are the contact numbers 50, 49, 43, 44. Okay, and next this one is spring charge contact. So what they have mentioned, some star they have given. So star means nodes here. I think I don't see any nodes. Let me check. No. Okay, and this is like when the spring is now I told NY means it is a spring charging contact, but it is open. Normally open means in discharge condition it is in open position. When the spring is charged, it will get closed. So this is so closed, and then the supply will extend here. And here you see some loop that in 181 TB to 182 TB. There is a loop. So and in between there is a resistor. So what for this means, and this breaker is you can say it can be used for 110 volt DC or 220 volt DC. Normally in substation we have 110 volt DC and then 220 volt DC. They have mentioned here for 220 volt DC, remove shorting link across resistor. So remove the shorting link across resistors. When you remove this resistor, then if you apply 220 volt supply, and then the voltage will be dropped, and this coil is rated for 110 volt actually. So for dropping this 220 volt to 120 volt, they used 200 watt 80 ohm resistors. And okay, then next if you short this, then this breaker can be used for 110 volt DC also. So you should confirm before wiring up your breaker whether it is 110 volt DC or 220 volt DC breaker. Okay, that is what I said. Check your nameplate detail, then your type and your drawing, and then your DC supply. Okay. Now, so once the supply gets connected, then this coil will operate and this will close the breaker. Okay, and what do you call? This is anti-pumping relay, and okay, this anti-pumping relay, and here anti-pumping relay. So it has contact 17 and 18. I think it's a breaker contact. Breaker is closed. it will get pick up. Okay, yeah. And breaker, yeah, this has like when there is a command, when positive extends, this here also positive get parallel path. So when the breaker get closed, it will automatically, that means if the breaker get closed, the positive will extend to here, and this will also this will be holded by this contact, self contact, until the positive is present. So when positive is present, this K9, that means you are keeping your TNC closed switch continuously. Then this supply to the closing coil will be cut by anti-pumping device by this anti-pumping self contact. Okay, self NC contact, and anti-pumping will be holded by its self contact, and anti-pumping is getting pick up when the breaker is closed. So hope you understand this circuit, and will be a very small combined with the trip circuit supervision and this anti-pumping in a single video. Okay, now this is your local closing circuit. Now we have completed our local closing circuit. Do I miss anything? Did I miss anything? No, I don't think so in this circuit. Now move on to our remote closing. This I'll explain what is this, and this one, and also this also I'll explain. This is your remote closing. So remote closing means closing from remote end. So now we so this positive is looped from here to 2P1 contact of the local remote switch. This local remote switch, if it is in remote position, then only this positive will be extended from 2P1 to 2P2. Then that is connected to this TV number 126, and it has a ferrule K5. Okay, then K5 226. Now you can take this wire to your remote end, and there whatever the interlocks or whatever the connection you want to make, and there also there will be a TNC switch at remote end, so you can connect that switch. And when it is closed, when it is like the same switch, consider the same switch at remote end. As for now, okay, we'll see in a CRP drawing what are the interlocks will be there in the remote section. Okay, so that we will see in another drawing. So this is a very basic 33 kV drawing, but most of the up to 220 kV levels you will have mostly same drawing. There won't be much difference anyhow. We'll see that differences also. So here also then again there comes K21, and most of the breaker, the final close command from remote will be K21 ferrule, and K5 will be remote positive. This you should have in your mind. K5 and K21. K5 is remote positive from breaker switch, and when it put in remote position, and then K21 is final close command from our remote panel. And this is your closing interlock if you want to extend it. Extended breaker side. Okay, it's again same scheme which I mentioned, which I explained you before. Okay, here also resistor, and this is also 110 volt coil. If you want to use it for 220 volt, remove this shorting and keep this resistor intact. Okay, now local tripping 1. So this is closing part. We have completed a closing part. Now this is a remote circuit. So remote circuit have what we call local remote switch. So and normally we don't use remote tripping through this switch. The reason behind is, suppose if we have taken through this switch, what will happen if it is in a local position and there is an emergency? If you want to trip this breaker, but you cannot trip, tripping is the main thing in a breaker. And whenever the fault occurs, a tripping mechanism or tripping circuit should be healthy, and it should operate as far as possible to clear the fault. So if you keep tripping positive through local remote switch for remote tripping, and that will create a issue when the switch is in local position. You cannot trip the breaker in emergency cases. So that's why they have. For remote tripping, they have directly connected this wire here. There is no interlock of local remote switch here. You can see. For closing, we have local remote switch, but for remote tripping, there is no local remote switch interlock. Okay. So from here, so when the switch is in local position, the positive will be extended from local to remote, and the number is K1, and here and it is connected to the TNC switch to the 1P3. And TNC switch, here there is a difference. You see here when this TNC switch is in closed version, it will extend. But this dot is here, T. That means when it is trip side, then only this positive will get extended. Okay. And here are some wirings, pre-close TCH and post-close TCH. These are we will see later. So why it is called pre-close? So pre-close and post-close trip circuit supervision we will see later. So it is actually post-close. They have mentioned by wrong pre. It is actually post-close. So and most of the breakers, Indian standards that we can see in India, or most of the breakers will have K23 as trip coil 1 final tripping command, and 23A is mentioned as pre-close trip circuit, heavier trip circuit supervision. 23AA is pre-close supervision. Sorry, this is post-close supervision. And okay, so this we will cover what is the purpose of this pre-close, post-close, everything we will cover in a trip circuit supervision relay session separately. That and this both will complete in a video, and we will explain everything. So here same the breaker contact. So we need to trip the breaker only when it is closed condition. So if it is already open, there is no need of tripping it. So that's why we have taken normal open contact. When this contact will close, when the breaker is closed, this contact will get closed. Okay. So when breaker is closed, this will get closed. Then positive will extend here. Here same the voltage dropping resistor for 110 volt or 220 volt DC option. And a trip coil gets supplied and it will trip the breaker. So this is the trip coil 1 and trip coil 2 circuit is here. Here you can see trip coil 2 mostly mentioned by using this ferrule K53, K53A, K53AA, or somewhere some breaker it will be mentioned 1K23, 1K23A, 1K23AA for the first coil, and 2K53, 2K53A, 2K53AA for second coil. Okay, and you should already I told you that this has a separate path from this one. So for that for the future, if you have two separate DC, you can connect independently. So this as I said, tripping is main important. So if one supply fails and you have another trip coil will be in service, which will trip when there is an emergency. So for that one we have, that means reliability, to increase the reliability. That's why they have given separate wiring. Okay. And this is nothing but DC monitoring. So I said alarm and indication circuit will have L ferrule, so that's it, they are using this is for the indication purpose. If this DC tripped or this MCB is tripped, or if it has any problem, that will be monitored using this contact wired at remote end. So that's why they have given this contact, and the wiring also L1 L2. I told L is used actually for indication and alarm circuits. It's the same case, L3 and L4. Okay, and I think hope you understand this drawing, the schematic drawing. Now they have mentioned we have to refer to sheet number 6. This is sheet number 5. We are going for sheet number 6 now. Okay, let me move to the sixth sheet. Okay, here. Okay, the supply comes there and here, and as I already it is a what do you call it, breaker contact. It's indication, sorry, it is a breaker, what do you say, breaker local indication lamp. So in breaker cubicil, control cubicil, local control cubicil, we have an indication that if your breaker is on or off, and we have this LEDs, and the breaker usually have mechanical indications like hinges in the cubicil, but you cannot add if there is no light or proper lighting at your yard, and then you may not able to see what is the actual breaker position. In that case, they have given these lamps, breaker on for breaker on and breaker off. Usually breaker on will be in red lamp, and breaker off will be in green lamp. And they also here when the breaker, as I already told, breaker when it is off condition, this is normally closed. Normally closed means this is in closed condition. When the breaker is off condition, the breaker is closed, it will open, and the normally open contact will get closed, and the positive will be extended here, and the lamp will glow. And this is spring charge limit switch contact. They have shown here, and this is actually for what is called remote indication whether your spring is charged or not. Even some manufacturer provide here also a lamp, a blue or amber lamp for your local for your visualization. So this is spring charge contact, spare contact. Okay, this is breaker spare contact, spare auxiliary contacts. Okay, so I told you these are called potential free or spare contacts. So that's why they are given numbers U1, U3, U ferrules. As I told you, U ferrule will be used for the spare contacts, and I have shown in the previous video. The same is here, you can see. Okay, and this is a breaker auxiliary contact box, which you might have seen in the breaker. Okay, so this is and this they have given remote indication completely wired up for the remote indication, so that you don't need to what do you call loop contacts directly. They have given loops and everything ready-made contacts, you can say, to your remote end wiring, remote end indication. So I think breaker control circuit is finished here. Now you will see the spring charging contact, spring charging circuit. So here you see I said AC supply will be mentioned using the letter H. Here you have the H. So this is an AC motor, and motor symbol here you can see M, and the spring charge limit contact. So this is your what is called AC supply. So that's why they have mentioned H1, H2, and this is your TB for external connection. So external supply will be given here. Now after the MCB, the number gets H1 to H3. So I told it will be a phase will be numbered odd numbers, and neutral will be numbered even numbers. So here H1 and H2, then H3 and H4, and this is for your monitoring. This is for your remote end indication. So that's why it is filled with L. Okay, so now it is H3. So H3 goes here, where then motor MCB, separate MCB for motor. Okay, and motor has a thermal overload relay also. If it is overloaded, it will trip. Okay, then this contact is spring limit switch contact. Is the spring is discharged, that condition it will be NC, it will be closed. So when the spring is discharged, the motor gets supply. So spring will be charged. So this is your negative circuit for H4. Okay, and then what else next we have? So the hatched line means it is in some other place, or it is in another cubicule. It is another cubicule. Okay, and now here we have a what you call toggle switch or door switch, we can say. So whenever the doors are opened, this close will get this switch will get closed, then your illumination lamp will be illuminated. So it is very useful for when you troubleshooting at night or at less light locations. Okay, then it is thermostat. Thermostat monitors the temperature, and when there is a they have given temperature range 30 to 90 degree centigrade and 15 ampere. Okay, so when there is a reduction in temperature, then there may be chances of rusting in your wiring or TB terminals. So that we should keep our whistle warm during winter season. So for that they have given this thermostat will sense. It has a setting you can set from 30 to 90 degree, whatever the temperature you need. And when you set when the temperature reaches that and temperature goes below the set temperature, then this will get the supply and the space heater will get on. So your computer will be warm, and there will be less chances of rusting. Okay, and this is here for socket. So if you want to use your kit during testing, or if you want to for that, if you need a supply, you can use for local purpose this supply. Okay, and hope you understand. This is the AC circuit, and I forgot to tell you. So this is a motor circuit, so that's why it has a ferrule M. So when you see a ferrule with M, it is connected to the motor. So already mentioned in my previous video, you can go and watch there, my second video of this series. So this is the overall 33 kV breaker drawing. Hope you understand. If you have any issues or if you have any suggestions, you can write to me or you can comment on the comment section. Please do subscribe. We will see in another drawing and 132 kV breaker, and then otherwise the 220 kV breaker. Then we will see control and relay panel drawing, and further we will move. And thanks for watching, and please share with your friends.